Alright, let's see how we can take some measurements for orientation tolerances for a part like this. Let's look at parallelism first. So we'll want to measure the parallelism with respect to the datum plane A. So I'm going to set datum feature A on a true geometric counterpart, very flat surface, a very precise machine surface, and with the measurement equipment set up with respect to the true geometric counterpart, what I'm going to do is then take measurements on the surface to see if this surface right here is parallel to the simulated datum plane A created by this true geometric counterpart, this surface plate that's very precise. And I just run it along the surface because parallelism is 3D, so it's the distance between two parallel planes that are exactly parallel to the datum plane A, which would be the bottom plane created by the high points of this surface right here. So that's parallelism. How would you measure perpendicularity? So to measure perpendicularity when it's called out like this, I would reset up the dial indicator to be set up to be perpendicular exactly 90 degrees to the true geometric counterpart that is creating the simulated datum plane A by having the bottom surface be in contact with that true geometric counterpart. We're simulating the datum plane A, and we set up the measurement equipment to be exactly 90 degrees to datum plane A. So now we can take measurements all along this surface right here. So that's how you measure perpendicularity. You want to make sure to get all around the surface, 3D, up, down, all of that. So now let's look at measuring angularity. Now looking at angularity, what we want to do is set up the measurement equipment so it's exactly the prescribed angle specified on the drawing. So this measurement equipment needs to be set up to be exactly 45 degrees to datum plane A, and we're simulating datum plane A again by having datum feature A be in contact with this true geometric counterpart, this surface plate that's very precise for measurements. And then while this is set up, we can move all along the surface looking for any dial indicator movement that is greater than whatever the tolerance value is. I'd move all along that surface. And because I don't quite have this set up super precise, you see the dial indicator moving all over the place, but if I was to have this set up right, we would be able to accurately see that. So another way that angularity is commonly measured is to actually incline the workpiece to the prescribed angle. Like I would put a pin here or something to make it right on the prescribed angle of 45 degrees, like this. And then what I would do is I would have the measurement equipment set up to be exactly in line with the true geometric counterpart, taking measurements all along that surface. That's another common way that we take measurements of the angularity tolerances.